You're listening to the AI Native Dev, brought to you by Tesla.
Hello and welcome to another episode of the AI Native Dev. And this is going to be a bit of a mashup episode where we're going to take a listen to a number of excerpts from previous episodes where we talk about whether we as organizations are ready to be able to say this product works better after these changes to my model. And this really takes account of various things, including eval testing, evaluations, regression testing, and so forth. This is going to be a mashup between Des Traynor, Intercom founder, as well as Rishabh Mehrotra, who's the head of AI at SourceGraph, Tamar Yehoshua, who is the president of products and technology at Glean, and lastly, but by no means last, Simon Last, the Notion co-founder and CTO. We're going to start off with Des Traynor's take. And one of the things that I love about Des Traynor is, of course, he recognizes devs love to ship code. And one of the things that is really important when we're using LLMs in our applications is we don't truly understand, we don't truly know if something really works until it's in production using real production data, real data that the users are throwing at it. And one of the lovely quotes that Des mentioned in his section is that with sufficiently simple tests, Des could be as smart as Einstein because the tests are so simple, they could both obviously do so well at it. In this section of the episode, Des talks about this wonderful thing called torture test, which is, in Des's words, all the psychotic scenarios that Finn, the Intercom tool, will get put into in the real world. So it's this set of torture tests that can really ascertain whether changes to the model, changes to prompts, etc., really do have an effect in production. So over to Guy and Des.
We have the dubious pleasure of building LLM-based products at Tesla. I've had some of that at Sneak. It's different. They're annoying. They are hard to evaluate whether you're doing your job correctly or not. Sometimes costs are different. CI/CD is different. Some of the tools are quite immature. And we're talking probably a year before that experience that I'm referring to here. How hard was it for a developer who previously didn't work in that surrounding to adapt it? How did you help the dev team, not just, hey, I reprioritize this feature, or am I overblowing the change?
The change is big. It's actually been a subject of a lot of internal debate. I'll give the umbrella answer and then we can get to specifics in a little bit. But generally speaking, everything about how we build software products changes when you bring in generative AI, probability-based systems, or whatever you want to call it. There's a classic product development is some sort of like double diamond. It's like research, make decisions, build, like ship, and then see if it works, whatever. You have like extra diamonds all over the place when it's like AI, because you don't start with, here's the user problem, let's solve it. You tend to start with, like, what's technically possible to begin with? And then you say, hey, does this new technical capability, let's say, hey, we can read PDFs in a second. Okay, does that map onto any problems that we have to solve for our users? And then you find one of those. And then you've worked out this thing can be built and it seems like it solves this problem. Even then, everyone's DNA in software is, so build it and ship it and move on to the next feature. What's the big deal? And I think the problem is once these things go live, you still don't know if it works or not. So you have to do so much. Whereas in typical boring bread and butter B2B SaaS, someone's, I wonder, can we merge expenses? Okay, so you get two receipts, you have to combine them. Oh, okay. If you ship that feature and people use it, you're like, great. You're not sitting here going, I wonder if it works. You're assuming that they're like the mathematics worked or whatever.
Yeah.
Whereas in all these systems, once it goes live, it goes through a whole other, like almost like product evolution, which is it actually working the way we thought it did? And obviously we do our best to not just test these systems on what we would call happy paths. A happy path is like, how do I reset my password? An unhappy path is, hey, my account is stored in my husband's name and it's my credit card and I need to move it to his credit card, but also we need to change address at the same time. That's where like these systems struggle massively. They're all brilliant at like, how do I reset my password? In the same way that like, if me and Einstein sit down and take a maths test and it's just basic arithmetic. I look as I'm as smart as Einstein. So you have to have this higher pass filter to get through, but nothing like reality bats last in AI. It's the last person to step up, and reality tells you like, hey, Finn works great in all these circumstances, but here's a pocket that it doesn't work in. Here's an area that I can't reach or whatever. Yeah. So I think the first thing I'd say to the question of enabling devs, empowering devs to work in this LLM first world is like getting out of your head the idea that things just simply do or don't work, because it's all a spectrum now. Getting out of your head that your core job is to just clarify or remove ambiguity. Ambiguity is all over the place. And your job is, there's like an art and science to like threading all the needles to finding the useful solutions. And that's before we've actually sat down in front of a text editor and started banging out code. That's in working out what problem we could solve, why we think it's solvable. Like most of your prototypes in this era are like written by like just prompting an LLM and seeing what it does with certain prompts and seeing what it does in response to certain asks. And if you can get to a consistent, reliable set of behaviors, then you can start to think about how would we productize this? What are the API calls? And then what's the UI look like? And then how would we describe it and all that? But you have so much like pre-work to do. All that said, there is obviously around any given like product, I'll take Finn because it's the one I know best. There is still a lot of like bread and butter B2B SaaS shit you have to build. Someone has to import docs and somebody has to have permissions and it has to be charged for it. So there's a pricing feature. Like it's not like you're an LLM engineer or bust. Yeah. It's the secondary features that fall into the classic. Like our reporting engine still draws graphs. That's not new.
Yeah. But just like any like engine, if you build any sort of proper product, at the end of the day, the engine is 10-20% of the surface of the product.
Exactly that. And I think there's a whole thin wrapper, thick wrapper debate that happens a lot in the industry. And I think like Finn is very much like a thick wrapper. There's a lot around Finn that needs to be there to make it work really well, such that the pieces are like the little like the resolution engine that sits inside of it. That is a part of the puzzle. It's a really important high impact part. But it alone isn't sufficient. It still needs the 16 other things, the vector search, the content import, and all that sort of stuff.
So it sounds like a massive change. It sounds like a lot of the changes is in the sum, the total of the product. There's a good chunk of people that are still working on things that don't require them to change their ways of working, but still a good portion that did, maybe in the total. So I guess are there some key takeaways? Like I'm sure you've tried things and some worked. You had a little bit of a head start because you did have some AI capabilities. But
we had an AI product live since I think 2017, 2018. So like we definitely had prior experience here. And that was one of the reasons we could move fast, because we were able to reuse a lot of our existing features. For example, like the vector search engine, we'd already built one for a previous product, et cetera. So that's one of the reasons why we were like out of the gates so fast. If I was to really say like the biggest lessons I've observed, like to be clear, what I'm skipping over here is I'm sure there are libraries and APIs and all sorts of stuff you need to read and get good at, et cetera. But I think to actually be a performant engineer in this era requires some amount of ability to interrogate data or perform data science to measure outcomes. To give you a very simple example, when we make a change, like we've run probably like 50 different A/B tests on Finn's performance. And it's very tempting. Everyone comes in who might join the group and say something like, oh, I have a cool feature I could add. How about we make it so that blah, like how about we make it so that it'll always ask this question at the end of the thing. And what you don't realize is like all of these things are different iterations of a resolution engine whose job is ultimately to, given a question, answer it. And if you break that, it doesn't matter how cool your little addition was. Now, the thing is, that's not a binary yes-no condition. It's like today, Finn's performance is about 50% of inbound support volume will be resolved by Finn. If somebody rolls out a cool feature that brings that 50 down to 40, that's a problem.
Yeah.
If they do that and don't even know to check or to realize or to look at its performance over a trailing 30 days or whatever, that's an even bigger problem. So there's very much you need to work out. You have to understand, the trick to working with these systems is to bottle up a probabilistic outcome and productize it. And you have to work out who is allowed play with the probabilities of that and understand that it's not like two different worlds. It's very easy for somebody in our messenger team to damage the performance of Finn, even though they don't write to that code base. But if they frame it wrong and they introduce Finn in the wrong way, it'll change what people write. And if it changes what people write, then it'll change how Finn performs. So it's really like the extra skill required here is the ability to assess, does this thing do the job it's supposed to do at a really high performance level. And you have to have some way to measure that, some way to test it, have bake-offs of different engines against each other, some way to have an acceptance framework for when, all right, that's been live for 30 days. No one's complained. It looks like we got a 4% increase in resolutions. Ship it. It's like that. None of those skills really existed before I'd say in most companies, but definitely not in Intercom.
Yeah, no, it sounds fascinating. I guess the good news is there's some analogy between what you're describing and the state of the art in terms of continuous deployment, right? If you're working with feature flags, if you're in Facebook and you're shipping, I forget the name of their sort of feature system there, to some gradual number of people, then there's some similarity of it. But this is much more en masse, much more predictable. And pretty much, does it kill almost substantially the value of a sort of CI/CD assessment for anything that isn't the more bread and butter SaaS piece? How much, having run with this now for a bit, how trustworthy or how revealing are the results of the synthetic tests or the CI/CD type, the pre-deployment tests that you have?
Yeah, I mean, we have two tests. We have one test we perform internally, which is expensive to run, which is like our torture test. So let's just say it's all the psychotic scenarios that Finn will get put into in the real world, but we want to make sure it doesn't like barf. So we don't do this unless we have good reason, but let's just say like GPT 4.0 drops or something like that, or 4.0. The tempting thing to do, and you'll see a lot of our competitors do this, is just, holy shit, new model, plug it in, we're good. And I think what that says to me is it speaks to the maturity of their rollout. Like, we also know the same API endpoints to ping if you want 4.0. It's like, it's not, we weren't sitting here going, oh, I wonder, how do you do this? It says our approach to such a scenario is, okay, let's first of all run this through the torture test. And our torture test is there to deliberately give us hard situations where we have a very clear outcome. So for example, let's say Tesla is using Finn. Would you want Tesla's bot to recommend competitors over Tesla? Would you want it to answer a tier 3 question? If it did know the answer, how would you want it to behave? Would you want it to make up an answer? A long variety, like genuinely hundreds of scenarios where most people agree on what the right outcome is, but like GPT 4.0 might not agree with that. So this is where like you have to control and contain the behavior. So once it clears the torture test, and we look at its performance, then we'll move to look, let's put this live. Let's see how it works in actual reality, which oftentimes is just...
But in a gradual fashion, like you wouldn't turn it on for everybody, you would graduate, you would...
Yes, absolutely.
Well, that's a great segment from Des. And one of the things that I love at the end that he said was, it's super easy just to drop in a new model into your application, but you really don't know what that means for users without that pre-testing and the evaluation testing. How does that new model behave? How is it going to change its answers to the same user question if you change that model? Really important to understand that changing is easy, but it's not the smart thing necessarily to do without that pre-test. So thank you very much to Des. Okay, next up we have Rishabh, the head of AI at SourceGraph. Now, Rishabh is very passionate about evaluations because he has a very deep history in machine learning. And one of the things that he talks about quite a bit in his piece here is about how you can test models with the 0 to 1 metric. And one thing, actually, really strong takeaway that he leaves us with is how writing a good evaluation is actually more important than training a good model. Over to Rishabh.
And testing is going to be very similar as well, right? If someone's writing code in their IDE line by line, and that's maybe using a code generation as well, like Cody, they're going to likely want to be able to have test step in sync. So as I write code, you're automatically generating tests that are effectively providing me with that assurance that the automatically generated code is working as I want to.
Yeah, that's a great point. I think this is more like errors multiply.
Yeah.
If I'm evaluating something after long writing it, then it's worse off, right? Because the errors, I could have stopped the errors earlier on and then debugged it and fixed it locally and then moved on.
Yeah.
So taking a step back, look, I love evaluation. In machine learning, I started my PhD thinking that, hey, maths and like fancy graphical models are the way to have impact using machine learning, right? And you spend 1 year in the industry, you realize, it's not about the fancy models. It's about, do you have an evaluation? Do you have these metrics? Do you know when something is working better?
Yeah.
So I think getting the 0 to 1 on evaluation on these data sets, that is really key for any machine learning problem.
Yep.
Now, especially
what do you mean by the 0 to 1 then?
Yeah, 0 to 1 is, look at like whenever a new language model gets launched, right? People are saying that, hey, for coding, LLMs, Llama 3 does well on coding. Why? Because, we have this human eval data set and a pass set one metric. Let's unpack that. Human eval data set is a data set of 164 questions. Hey, write me a binary search in this code, right? So essentially, it's like you get a text and you write a function. And then you're like, hey, does this function run correctly? So they have a unit test for that. And if it passes, then you get +1, right?
Yeah.
So now this is great. It's a great start. But is it really how people are using Cody and a bunch of other coding tools? No, they're like, if I'm an enterprise developer, if let's say I'm in a big bank, then I have 20,000 other peers and there are like 30,000 repositories, right? I'm not writing binary search independent of everything else, right?
Yeah.
I'm working in a massive code base, which has been edited across the last 10 years. And there's some dependency by some team in Beijing, and there's a function which I haven't even read, right? And maybe it's in a language I don't even care about or understand. My point is, the evaluation which we need for these real world products is different than the benchmarks which we have in the industry, right? Now, the 0 to 1 for evaluation is that, hey, sure, let's use pass it 1 in human eval at the start on day 0. But then we see that you improve it by 10%. We have results when we actually did improve pass it 1 by 10-15%. We tried it online on Cody users and the metrics dropped.
Yeah.
And we're writing a blog post about it at offline-online correlation.
Yeah.
Because if you trust your offline metric, pass it 1, you improve it, you hope that, hey, amazing, users are going to love it.
Yeah.
It wasn't true.
The context is so different.
Yeah, the context is so different. Now, this means that I got to develop an evaluation for my feature. And my evaluation should represent how my actual users using this feature feel about it. Just because it's better on a metric, which is an industry benchmark, doesn't mean that improving it will improve actual user experience.
And can that change from user to user as well? So you mentioned a bank there. If 5 other banks, is it going to be the same for them? If it's something not in the fintech space, is it going to be different for them?
That's a great point. I think the nuance you're trying to say is that, hey, one, are you even feature aware in your evaluation? Because pass at 1 is not feature aware, right?
Yeah.
Pass at 1 doesn't care about autocomplete or unit test generation or code fixings. I don't care what the end use case or application is. This is just the evaluation. So I think the first jump is have an evaluation data set which is about your feature, right? The evaluation data set for unit test generation is going to be different than code completion. It's going to be different than code edits. It's going to be different than chat. So I think the 0 to 1 we were talking about 5 minutes earlier, you got to do 0 to 1s for each of these features.
Yeah.
And that's not easy because evaluation doesn't come naturally.
Yeah.
And once you have it, then the question becomes that, hey, okay, once I have it for my feature, then, hey, can I reuse it across industries?
Is it testing now? Is it guardrails that become the most important thing? And almost, I would say, more important than code? Or is still code the thing that we need to care about the most?
Yeah, I think like, if I view this extreme of like, again, if I put my evaluation hat, right, I think I want to be one of the most prominent vocal proponent of evaluation in the industry, not just code AI, in the machine learning industry. We should do more evaluation. So there I would say that writing a good evaluation is more important than writing a good model.
Yeah.
Writing a good evaluation is more important than writing a better context source, because you don't know what's a better context source if you don't have a way to evaluate it, right? So I think for me, evaluation precedes any feature development.
Yeah.
If you don't have a way to evaluate it, then you're just shooting darts in the dark room, right? Some are going to land by luck. Now there, in that world, right, I have to ensure that unit tests and evaluation is like ahead in terms of importance than just like code. That said, I think overall, right, what's more important is like task success, right? Which is, again, what is task success? You're not just looking at unit tests as an evaluation, you're looking at evaluation of the overall goal, which is, hey, do I do this task right? And then I think if that's where, as an orchestrator, if I start treating these agents, could be code autocomplete or like any specific standalone agent powered by SourceGraph as well, probably. So in those words, evaluation of that task, because you are the domain expert. Assume AGI exists today. Assume the foundation models are going to get smarter, like billions of dollars, trillions of dollars eventually into it. We train these the smartest models and they can do everything. But you are best placed to understand your domain on what the goal is right now, right? So you are the only person who can develop that evaluation of like, how do I know that you're correct? How do I know whether you're 90% correct, 92% correct? And again, right, the marginal gain on 92 to 94 is going to be a lot more harder than going from 80 to 90, right?
Yeah.
It always gets safer. Like, I mean, there's going to be like an exponential hardness increase over there. So essentially the point then becomes purely on evaluation, purely on unit test, right? What are the nuances of this problem, of this domain, which the model needs to get right? And are we able to articulate those, and are we able to generate those unit tests or generate those guardrails and evaluations so that I can judge how the models are getting better on that topic, right? So the models are going to be far intelligent, great, but then what is success? You as a domain expert get to define that.
Yeah.
And this is a great thing, not just about coding, but also like any domain expert using machine learning or these tools across domains, you know what you're using it for, right? The other AGI tools are just tools to help you do that job.
Yeah.
So I think the onus is on you to write good evaluation, or even, I mean, maybe tomorrow LLM as a judge, and like people are developing foundation models just for evaluation, right? So there are going to be other tools to help you do that as well. Code foundation models for like unit tests, maybe that's the thing in 6 months from now, right? The point then becomes, what should it focus on? That's the role you're playing. Orchestrating, but like orchestrating on the evaluation. Oh, did you get that corner piece right? Or you know what, this is a criticality of the system, right? And again, right, the payment gateway link and the authentication link, some of these get screwed up, then massive bad things happen, right? So you know that. So I think that's where like the human in the loop and your inputs to the system starts getting crossed.
Great stuff from Rishabh. Next up, we're going to be hearing from Tamar Yehoshua, who's the president of products and technology at Glean. And Glean's a really interesting company. Effectively does enterprise search across a vast number of sources, many of which have very sensitive data, including HR systems and various things within that enterprise. So Glean as a product allow multiple models to be used, and the user can select which one they choose to use. Glean, interestingly, obviously don't have access directly into that data because that data is very sensitive to the customer. So when it comes to thinking about how Glean would test and run evaluations across multiple models with data that they don't have access to, it becomes a bit of a challenge and makes evaluation testing very hard. Now, one of the really interesting things that was talked about in this episode was how Glean use LLMs as a judge and as a jury. And it's a really interesting concept of not necessarily having employees from Glean look at the prompts and the queries that are being created and try to validate them, but that's actually about having an LLM do that validation. So the LLM is determining whether those queries are correct. And of course, that determinism is very hard as well. So having that jury perhaps lessens that non-determinism effect of an LLM. So this is another great episode. And so over to Guy and Tamar.
So I guess let's talk. Indeed, I keep promising talking about the sausage making. Let's do that now. I guess what is it like building a product that works this way? The results of the product vary by the data that comes in. The success rates are very different, and that's on top of the fact that the LLMs move at such a kind of lightning pace, and so you get new models all the time. And if I understand correctly, you actually even don't pick the model. You have to work with models that the customer does. So maybe tell us a little bit about how do you interact with the models, or just to set that. But what I'm really interested in is you talked about LLM as a judge. You had a post about this. Just how do you know that your product works?
It's very difficult. No, it's the non-deterministic aspect is the most interesting and challenging. My first week at Glean, I was talking to the head of the assistant quality team just to learn, what do you do and how does it work? And realize that a lot of their time was spent talking to customers who did not have the right expectations of what it could do, or were complaining that it was non-deterministic. I did this query once, I did it again, and it didn't get the same thing. And we're starting to get used to ChatGPT and the concept of non-deterministic, but in an enterprise, you're a CIO, you buy software, you pay a lot of money for it, you expect it to have the same answer every time. And so one is getting our customers comfortable with what LLMs can do and what the boundary conditions are is part of what we have to do in our product. And it can't just be in the marketing and in the enablement. You have to have some way in the product to take care of this as well, to understand what are the challenges going to be for people. So I explained the RAG architecture. So we have our way of evaluating the search, which most of the team came from Google Search Ranking, built eval tools just like Google Search had. So that's like bread and butter. Like, how do you eval search? We have a whole process for eval.
This is not the user side. This is internal. This is to
This is
evaluate whether your search is working correctly with information the engineers see, your engineers.
This is our ranking. The ranking algorithms with a lot of information on exactly what was triggered and what wasn't, and what scores it had. Now, it is a little bit more difficult because at Google, you could use third-party raters to say, here's a change we're making. Is this change good or bad? Evaluate it. But because this is enterprise data, we can't use third-party raters. We can only use our tools and engineers to look at the data. So that's another wrinkle on top for enterprise. But going back to your question of what's different is understanding the user mindset, when they're using this product? How do you help them through that to give them guardrails so they can better understand what the product can do? And then how do you evaluate it?
Yeah.
And how do you make sure that it's working as intended with this new technology that nobody fully understands why it's giving the answer that it does?
Yeah. What are some examples of things that you would do in the product to help people understand this?
So a big one is suggest. One of the things about Glean is that we understand your organization. So in the connectors that we do, we also have a Workday connector, Active Directory, so we understand who you are, who are your peers, who's on your team. So we can suggest prompts that people in your team have been using. Oh, you're a PM. Here's a prompt from another PM that the things that they've been doing that you might want to try. And so we can suggest, or generic suggestions. We've been experimenting with all different ones, but that can help guide people into areas of this is ways that you can get value. And that's going to be really important. And we want to do a lot more of that. And the Glean apps was a big way of doing that as well. Here's some more structured prompts and triggers. This is where, if you have an IT question, you'll go here. If you want to build a customer brief, here's a Glean app for building a customer brief. So that helps people go to things that somebody has curated. Somebody, like the 5% of people in the company who really understand how to work with prompts and LLMs, they're going to do that and they're going to help. And we're going to be doing more and more of that. And I hope that is a way, that's a whole nother angle of how we are doing that. And then we also have just teams dedicated to eval and understanding what changes need to be made, what don't, how to evaluate new models. As you mentioned, customers can decide what model they want to use. We validate the model, we certify it, I should say. If a Gemini 1.5 Pro comes out, so we will certify it for our customers before we enable them to use it. But we have let our customers pick OpenAI, Anthropic, or Gemini for the LLM aspect of the work. And so that's another thing that's tricky also, is working with the different models.
But how, so I understand it, like the suggest notion or the idea of disseminating, actually probably a useful practice for any product, not an LLM specific one, which is take the forerunners and provide an easy way to disseminate their sample uses to the rest of the organization. But on the other side, in terms of what happens if it fails, what happens if hallucinations are a thing in this world. So ranges from okay, maybe you're good on the search side, so it finds the relevant data, you feel pretty good, but didn't understand it, did it process it correctly, did it present it correctly? How do you evaluate it when you certify? What types of tools are at your disposal to know when you're using a new model or even just evolving your software that it got better?
So first of all, in the product, customers can do a thumbs up, thumbs down. Obviously, we get more thumbs down than thumbs up because that's just the nature of people. But that's helpful until all those queries come back to us so that we know here's a set of bad queries. We also evaluate things like in search. It's easy. Did somebody click on it? Did they find what they were looking for? In Assistant, it's trickier because they might have gotten the answer or not gotten the answer. But for example, if they try a couple queries in Assistant and go to search afterwards and then find the document that they needed, we know that the Assistant didn't give them the answer. So we have a metric, the satisfaction index from search in the Assistant. So we look at that and we measure that very heavily of how many bad queries did we get, how many thumbs down did we get. So that's one.
Yeah, and that's those are all things that observe people using the product.
Right. That's the proxy for how well are we doing. And if we're doing hill climbing to improve, is it going up or going down? And then evaluating is super tricky. So we have, as you mentioned, we've started using LLM as a judge. And there are many ways that the LLM could go wrong, or the whole assistant could go wrong. It could pick the wrong query to send to the retrieval engine. The retrieval could not find the document. It could find the wrong one, or it could miss something. And then in the generative, not be a complete answer. It could not be grounded in the facts. It might pull in public data instead of the data that you had. And then, so you've got the completeness, the groundedness, and the factualness. So we've been using LLMs to judge our answers for the assistant in these different areas. So completeness is one that we get the most thumbs down. If it's not a complete answer, we'll get thumbs down for it. And then we've correlated the thumbs down with LLM as a judge, and the completeness. So that's the most easiest for an LLM to then evaluate the results of the LLM.
Yeah.
And so we have completeness, we have grounded. Did it tell you which context it came from? And then the factualness is the hardest. And the factualness, what you need is a golden set, essentially.
Factualness being you did not hallucinate.
Grounded is more the hallucinations.
Okay.
We don't have a big problem with hallucinations at Glean because of the RAG-based architecture and because we do the citations. So the groundedness is the most aligned to hallucinations, but sometimes it's not grounded in an enterprise doc because it might be like the stock price that you ask for a company, and it might just be public knowledge. The factfulness is, LLMs are very confident. So they'll say with great confidence that something is correct. And then a user will not thumbs down those because they'll just assume it's correct. And those are the most dangerous.
Right.
And that what we're doing is trying to actually have a golden set. We're having an LLM extract queries from documents and then measure the effectiveness of, are we finding them? So we get the golden set, and then so this one, actually, we're still working on the fact how to best measure it. But the best part that we've done now is we have a repeatable process for LLM as judge. We have an eval framework of how we use, and we can just churn the crank when a new model comes out, and we can get an evaluation across these metrics for new models and for changes. As we're making changes in the code, we can evaluate them more easily. Is it perfect? No, but it's a lot better than engineers manually going and looking at every query.
And looking at the results. And that golden set needs to be created per customer?
So a lot of times we use our data for some of these golden sets to make sure, but we do have in our eval, we actually run queries in our customer environments, in their deployments, because we can't look at their content. But we can run things and evaluate them and get the results of the evaluation.
So that's interesting, and that's a good learning. So you can't look at their data. You have to make sure that your check did not cause problems with their data, or at least try to assess that's the case. So what you're agreeing with them is that you'd be able to run some processes that are not actually functional, or run a bunch of these tests on their platform with their data. But you won't access the data, you'll just get the results of like thumbs up, thumbs down. For a different version of the thumbs up, thumbs down to say, yeah, it feels good for you to deploy this new version or to upgrade to this new model, etc.
We're very cautious of making sure we have very strict agreements of how we're handling customer data. But we absolutely run regressions, and it's an interesting process that we've gone through.
Yeah. And so we talk about LLM as a judge, which is the LLM looks at the answer and says the result I see in the golden set seems sufficiently familiar, sufficiently similar to the result the live product gave right now. And then I found interesting in the blog post that you wrote about this. There's this notion of LLM jury, which I don't know, it has the risk of taking the analogy a bit too far. But I guess do you want to say a couple of words about that?
It's exactly what it sounds like. Just multiple, you want to assess not just one voice, but multiple voices to make sure that you're aligning.
And I guess partly a means to deal with the fact that LLMs themselves, like the evaluator itself, is a random or is a non-deterministic entity. So oddly, actually quite aligned to the reason there is a judge and jury in the actual human judicial system.
And last up, we have Simon Last, Notion co-founder and CTO. Now, Notion AI is, of course, one of the most impressive running real-world applications of AI. And in the snippets that we're going to be sharing with you today, one of the interesting things here is about how Simon details how Notion effectively log failures that are occurring with exact reproduction capabilities. And what this allows them to do is effectively build up a data set of failures with regressions. Now, there's an iterative improvement loop here whereby one can collect the failures, adjust prompts, rerun the evaluations, and then validate the fixes against those evaluations. So it's a really interesting loop of how there's a continuous improvement with validation from the evals as well. And of course, one really important thing is there needs to be an opt-in from a privacy point of view. There needs to be that opt-in for data sharing for evaluation purposes only, that allow and ensure rather that privacy and segregation from test to production data. So Here's Simon, co-founder of Notion and CTO.
Yeah, I'm very curious to dive in because indeed some things are the same and you just want to tap into them, and some things are quite substantially different. But I guess still on the organization, do you think about the team that is originally building it as a platform team? How did you consider that division now that you've been building this for a couple of years and you have, it sounds like, multiple teams working it? How do you think about the shared infrastructure, if you will, between those, or the shared learnings or evaluation methods, as we'll touch on in a sec? How do you think about, I guess, enabling these other teams to adopt AI more easily?
Yeah, that's a good question. Yeah, initially we didn't think of it that way. It's more just like a end-to-end product team. The only goal is just to
ship things.
Yeah, just to ship useful stuff, and then we're learning along the way how to do evals. And then our goal is to make it more of a platform team. So we're trying to take what we build and expose it as something reproducible. I would say it's actually pretty tricky because in many ways we don't really do any training of models. It's all about taking the best models out there and packaging them into the product and making everything work well, which involves doing logging in the right way, like setting up your prompt, doing logging in the right way, doing evals, all that stuff. And it's interesting. Most of it is actually, there's not that much technically challenging, I would say, about the platform aspect. A lot of it is more about the best practice of how you do it and the knowledge of what steps you take and even how to think about it. Yeah, it's a tricky thing to get other people to work on without context. What we've had most success with actually is when someone new wants to work on AI, we've had a lot of success with just having them join the AI team temporarily. And then they just join our stand-ups and get in the weeds with us every day. And then quickly pick up all the context around like how to do evals, how to iterate on prompts. And yeah, we found it challenging the other way, where we just like give them like the code pointers to all the different layers of the stack.
Here's the thing that would run the inference or whatever it is. But
yeah, and the code isn't that complicated. I would say the complexity is actually more in like the best practice of how you do things and the mental model. I don't even think about it.
Yeah. I think that makes perfect sense. I actually had Patrick Dubois, who was a big kind of DevOps luminary, on the podcast, and we talked about how the analogies work from the DevOps era. And a lot of it is indeed about platform teams and reuse, but also about embedding and about someone's walking a mile in your shoes a little bit and learning, both for empathy, as you might get annoyed later on when the product doesn't work quite as you want, but for skill sharing and in security. And DevSecOps we use the same approach. I think we're running out of letters we can add into the DevSecOps kind of combo. I think we need to find a new strategy there, but I think the approaches themselves work quite well. I love that approach, and it makes perfect sense to me. Maybe let's indeed, I want to talk a bit more about the skills and those gaps, but maybe let's first describe these. What has been repeated oftentimes in this, probably said most succinctly by Des at Intercom in an early episode here, is that it's really hard to know whether your product works when you're building on AI. So I guess what has your experience been when you're building these capabilities? How do you think about evaluation, about testing, about knowing whether it hit a threshold, but also knowing whether it hasn't regressed?
Yeah, it's super hard. It's a really different experience than the pre-AI world. Most of my experience is in building Notion, building products, and it's been honestly really painful. It's very exciting and fun, and like I'm pretty obsessed with the new technology, but it's very painful, and I often miss the old world. In the old world, I could have an idea, and it might take me longer than I thought, but I could definitely ship it. But in the AI world, I can often have an idea and then be surprised that didn't work in some way I didn't expect. I would say, I guess the way I think about it is it's a twofold challenge of, one is for the situations that you test, you need to make sure that those work and they don't regress. And then there's this nebulous space of things that you haven't even tested. And it can be arbitrary. And then filling enough of that space so that you're confident that it's going to match the distribution of what users are going to request enough that you're reasonably confident. You can never like fully match it. Yeah, I guess the way I think about that is, yeah, you need like a repeatable system or engine around this. And the key pieces are something like you need to set up good logging such that interactions can be called up again. If it fails in some way, you can go look at that. And it's extremely important to be able to exactly reproduce the failure situation. The log has to be an exact reproduction of the error, and then you should be able to just rerun that inference with the exact same input.
Right.
That's really important. If you can't do that, you're totally screwed.
And that creates probably some challenges, like I fully relate to the full logging, even more so than in regular instrumented systems. How do you work around the kind of the privacy concerns or some of the user data concerns around it?
Yeah, so we take that really seriously. What we do is we have an opt-in early access program. So when you use Notion AI, we show you this little pop-up, and the default is no, but you can opt in to sharing data with us. And we don't use it for training. It's just for evaluation. So basically, that allows us to see the logs. Like if you thumbs down, we can actually see the log with the input. And then we can add it to an eval data set. And we segregate out the prod data to make sure that it's not contaminated with other sources. But yeah, that's been extremely helpful. Let people opt in. And our user base is large enough that even if a pretty small percentage opt in, it's still quite a lot of data.
So logging is one.
Yeah, so logging is one. So yeah, I would say the next step is around collecting the failures into data sets. That's pretty important. So yeah, just like organizing them in some reasonable way such that for the given task, you have some data set or data sets that are like, these are all the cases that we care about and all the known previous failures. And then the next bit is being able to evaluate that a given failure is still happening or not. And that can be really hard. There's many ways to do evals. I think about you can have deterministic or non-deterministic evals. Definitely best use deterministic when you can, and then you can use like a model grade eval when not. For model graded evals, they work best when it's as concrete and specific as possible. I've seen people fail a lot doing model graded evals when it's like too generic or the task is too difficult. I think I said this in the last one, but if your model grade eval is not like robustly easy for the model, then you have to have an eval for your eval. And you just created like a new stack of problems.
An infinite loop. So it relates to the data piece. So the data sounded like going further back, you have to create a set of test cases for the things you want to work, and then a set of cases for problematic ones. I guess that's synthetic. That's at the beginning as you build a feature, and then you need to have access to real world scenarios, and you curate out of that data set of failure cases with the proper user permission, like amidst the users that opted in to help improve the system. I guess, do you accumulate over there good cases as well? Does the data set mostly grow in the negative sense of don't do this, or is it the same one? Is it basically because you're like, here's a scenario, here's the correct and here's the incorrect answer?
I tend not to care about good cases that much. I think the main focus is on, because what's the actionable value of that? Maybe it's nice to have a few of them just as a sanity check, but to me, the main goal is to collect concrete regressions and then fix them and then make sure that they stay fixed. And then over time, you're ratcheting up all these things that they used to not work are now working, and then you're growing a data set of things that continue to work. And that's ideal. You'll often find issues that you just can't really fix. And so that's part of the...
Yeah, we'll come back to that. That's really interesting because my product works at this percentage of...
Yeah, the models have limits. There's many issues that we can fix. And we're not a foundation model company. It's like, all right, we'll just wait till the next model comes out. Hopefully it'll fix this one. Yeah. So you want some kind of eval. It could be just like a human grade eval, although that'll quickly get out of control. Then the really key next thing is you need to enter this loop where you find some new regression, you add it to your data set, then you change the prompt in some way, then you rerun the examples in the data set, and then you need to be able to decide whether it's like better or worse. And ideally that's as automated as possible, and then ship that change. And then there's just this constant loop of new example, improve the prompt,
grow the product. And I think on the eval side, Notion is pretty open or flexible in what you can do with it. There are a lot of degrees of freedom of it. It's easy to think about non-deterministic evaluations that you can have in Notion as you're looking at text and unstructured data and the likes. What's an example of a structured evaluation that you can do in a Notion AI capability?
Yeah, a lot of them, like anything to do with formatting the output in some way. Maybe it's XML, maybe it's JSON. That's ideal. I think about if you're having some issue, the best way to solve it is by solving it with a validator. Make it so that the invalid output is impossible by structuring the output in some way where you can deterministically say that the bad output is incorrect. So that's like the best way to solve any problem, and it's the easiest way to evaluate it. Another deterministic eval that we use all the time is I love using mini classifiers as part of the flow. Classifiers are really great. By classifier, I just mean some inference that outputs like an enum, like set of possible values. Classifiers are really great because they're really easy to eval. Because the output...
You classify the result of the product's activity, like you classify the output from the LLM?
No, actually, that's part of the flow. So, for example, one thing we need to do as part of the chat experience is decide whether to search or not, just as an example. So it's, should I search, should I not search? Like yes or no, basically. These other classifiers that have more than two possible values, but yeah, those are really great in large part because they're so easy to evaluate, because you just have this ground truth output and then you just compare the actual versus expected. It's really great for that reason. You can collect a big data set and you can get a score
Yeah. And I guess what has been the driver behind the choice not to fine tune, or actually, you know what, I might be jumping to conclusions here. You said you're not training foundation models of it. Do you find yourself fine tuning the model?
Yeah, so we've tried fine tuning extensively. I've personally banged my head on it a lot. I think I need to ask OpenAI, but I feel like I'm, if not the highest, maybe like 99th percentile, like number of fine tunes created. Yeah, we try fine tuning quite a lot. I would say, yeah, the big issue with fine tuning is that you're making your job like 100 times harder, at least, because I need to collect this whole data set. The actual fine tuning process can be difficult, especially if you're using not just slower. You have to wait for things to train. And then it's really hard to debug issues. You're basically like creating this black box where any of your new examples, as you do the successive fine tuning runs, any new examples can poison the entire data set. You can mess up the model. So it really requires you to have extremely good evaluations, and it's really hard to debug issues. So I've had issues with fine tuning where, you know, I literally would spend weeks trying to figure out what the problem was, and just extremely hard. Yeah, I would say I'm honestly not that bullish on companies outside of the foundation model companies doing fine tuning. And if I like meet a startup and they say they're doing fine tuning, I actually now think of that as like a negative update. It's
A
like
lack of experience. You buy into the promise, but it doesn't actually
yeah, it sounds
justify
cool.
itself in the real world.
And I got bit by this bug too. Like it sounds so cool, and like I think as engineers we want to have more control. We want to do a technically cool thing. You know, the technically like powerful thing, and I was totally susceptible to that, and it was really fun to do it. But I don't know. I'm a huge fan of in context learning. Like it's gonna get better. Yeah, there's a lot of reasons to do it. Another big reason not to fine tune is if you're not a foundation model company, you really want to just be using the best model at any given time, and the progress is so fast. And so if something doesn't work now, there's a good chance it's going to work in the near future. And if you're fine tuning, you're really just locking yourself in to this slow, complicated process that makes it hard to update. In context learning is amazing because if there's a new model, I can switch the next day.
And I guess in that case, so that was my next question, is like how often do you try different models, and how rigorous a testing process do you feel is necessary to make that switch? Because those are probably new features, you control the timeline. A new model comes along, I guess you still control the timeline of how quickly you roll it out. How do you think about the trade-off between wanting to tap into the new hotness versus, I don't know, potentially slow? Or how confident do you feel about, hey, like the next one came out, can I sort of slot that in and get it out within the week?
Yeah, that's a good question. I would say the speed at which you can do it is really dependent on the quality of your evals. How good do your evals, like how good are they at telling you confidently that this change will improve the overall experience? Yeah, I would say that's one of the reasons why evals are so important. Probably changing prompts is more important than changing models. That's going to happen much more often. But I mean, the same evals work for both, right? But yeah, we've definitely invested a lot in really making sure the tools are right and the evals are really good. But also, I would say as a products company, I think it's pretty important not to be just like jerked around constantly by new models coming out. I think it's important to like think about like really understanding the task that you uniquely really care about for the product. And your alpha should be really deeply understanding the task and what it means to produce a good result and the product experience around that. And like watching new capabilities and releasing them as they come out. I think it's really about you and your product, and like thinking about the models as like a means to an end to enable that. And very often a new model, like just it's like shiny and cool, but like maybe it just doesn't really get you much benefit for the task that you care about.
Yeah, I'm curious now, what's your favorite eval example? Is it just that, like
Oh,
specific code base?
it's an app. Yeah, so it's it's a pretty simple app, but it touches all the pieces that I think are interesting. So it's a calorie tracking app. All it is it's a table of where it's the food and the amount of calories, and then there's an input, and you can just type whatever you want, and then it's supposed to extract out each food item and the calories and add to the table. So it involves a database, a backend, a front end, and then it also has to write a prompt and call into a language model to do the extraction. And last time I tried, it actually did get the initial version, and then I asked for just one small feature change, and then it didn't work from there.
and then
So
it broke.
they've made huge improvements, and it's like super impressive. But yeah, I feel like we're not quite there yet still.
And a massive thank you to Simon there, and of course Tamar, Rishabh, and Des at the very start of the episode, and of course my co-host Gaipo for helping host many of those sessions. This has been a very interesting episode for me personally, just because it's been really nice going through some of the past episodes and also picking out some of those learnings that are consistent and common from many leaders who have kindly given the time to share their thoughts and learnings with us. Let us know what you think. If there's other topics that you feel are common across episodes, let us know. We'll create some further mashups of them. Till then, thanks very much for listening again, and tune into the next episode.
Thanks for tuning in. Join us next time on the AI Native Dev, brought to you by Tesla.